Hi, everyone. Thank you so much for joining the Learning Lab today. I'm Lisa, and this is Manfred, and we're going to be, well, Manfred is going to be talking to you about Chainguard Libraries. I'm doing the introduction, but I'll be around in the chat. Happy almost Halloween as well. If folks are going to dress up this tomorrow or this weekend, I'd love to hear about your costumes too, especially if we have anybody going as a vulnerability or something fun like that. With lots of numbers at the end. Awesome. So this session today is about Chainguard Libraries. We're going to be focused on JavaScript and the Python CVE remediation, which is very topical if you're going to address as a vulnerability, of course. Next Learning Lab is going to be November 20th. And that will be featuring Erica Heidi, and she's going to be talking about Chainguard OS, which is the operating system, the container-first operating system that we built in-house that's underneath our Chainguard containers and Chainguard VMs. And she's also going to be doing a demo about the Raspberry Pi running Chainguard OS, so that'll be super fun and very nerdy. So we hope to see you then. And I will turn it over to Manfred now, and thank you all for coming.
All right, thank you so much for the introduction, Lisa. And by the way, props also to Erica. She made some awesome 3D printed Halloween Linkies. And if you are dressing up as Linky as any of your Halloween costume events, also let us know about this. But for now, let's talk about Chainguard Libraries rather than Halloween. First of it, myself, Manfred Moser here, long-term open source hacker, Java developer, with a background in Trino, Maven, Nexus, and stuff like that. I'm in Canada, and I go mountain biking all year round. Currently, there's no snow, but it's soon going to look like that again. But let's move on to what we're going to do today. First, I'm going to give a bit of an introduction. We'll talk about the fundamental concepts around Chainguard Libraries, and then we'll dive into the specifics. As you know, Chainguard Libraries for JavaScript is pretty new. It's a closed beta, and I'll show you that in a demo and where we're at. And then we'll do a bit of CVE remediation on libraries. I'll tell you what that even means. And then I'll do a demo on that for Python project that I have set up for you as well. And of course, as Lisa mentioned during the training, please do throw your questions on the chat, also interact with each other. I might not be able to answer them immediately, but Lisa will try to answer. And also we have a little bit of a QA at the end where hopefully I can answer the rest of them. And if not, we might have to organize another webinar, or you can find us also on the Chainguard community Slack, where we also try to answer questions as much as we can. So, as you know, Chainguard is about secure containers, and that's all great and everything. I'm not going to tell you about all that. A secure container is kind of a base for running your application, but that's also great. But what's inside that container is kind of very important, actually. And also, in that container, hopefully there's at least one application, or there's multiple applications, and those applications then are composed of libraries. So libraries is really very, very important, because a container with just an operating system doesn't really do much for your business. And beyond that, applications also run outside containers, right? They run on hardware racks, straight on VMs, as the Chainguard VMs product also potentially enables. They run on hardware, they run all over the place, but all of those applications are built with open source components, and those are what we call libraries. And yes, we call them libraries. Other application platforms and stuff have different names, like package or dependency or framework, toolkit, whatever. We just chose one name, and we chose library. And those are the building blocks for your application. They provide a specific feature set, such as, really good logging or JSON parsing and stuff. And they go beyond what your language provides, right? Like, that's also different, right? Like, as you'll see later on, JavaScript as such as a language is very small, and it doesn't have many standard libraries, but it has a massive ecosystem of additional libraries out of the open source community. In my prior learning lab, we talked about Java and Chainguard libraries for Java. The class path and like the default libraries in Java are very powerful, and still there's more libraries to provide lots of functionality. So when you look at any application that you are like working on, about 70% or more, all the way to 90% of that application is created by library. Even if you're one of those cool kids that does vibe coding, well, the vibe coded application will also use like React or whatever for the web interface. So they are also using libraries. So there's no escaping those libraries, and they're typically open source and come in all shapes and sizes. Why is that important? Well, in order to consume those libraries, they must get to you as a developer at your company on the right. And they go through quite a complex journey. There's some maintainers on the open source project. They write the open source code, put it in a GitHub repository, then it gets built into binaries and then distributed. But on that journey, there's numerous attack surfaces where people can sort of like, sneak in stuff that you don't want to have ending up at your company and your development workstation. And we've seen this happening recently again all the time. And what Chainguard Libraries does is it eliminates those supply chain attacks that go anywhere between the source code and you. So everything that's dealt with on the open source ecosystem, like the build on GitHub Actions or whatever, someone's local build on their computer, the credentials to go to the distribution, like the npm registry or the Python package index, and then the transport from the distribution, that public repository into the network of a company, all that stuff is eliminated by Chainguard Libraries because we take care of all of it. We build from source, provide our own binaries straight to you in an authenticated manner. So all the supply chain attacks fall by the wayside and you don't have to worry about that. So Chainguard Libraries builds that same approach that we've done for our operating system, so Wolfie / Chainguard OS, to libraries where we build from source. And we do this for JavaScript, Python, and Java at the moment. But today we're going to focus on JavaScript and Python. So let's start first with Chainguard Libraries for JavaScript. As you can see here, I have the JavaScript logo, but there's also a whole bunch of other logos here. And that's important to understand. The JavaScript ecosystem is more than just JavaScript, right? Like there's TypeScript, and then there's all the frameworks on top of it that some people don't necessarily realize they're all intertwined, like React and Node and npm. All of those tools and many, many more are all part of this Chainguard Libraries for JavaScript feature or product and the larger ecosystem that we support. So JavaScript, as I mentioned, is very, very large, right? There's two languages that are typically used. JavaScript, the original language, used then to get standardized under the name ECMAScript and whatever. But the main differentiated language is the TypeScript language that came out of Microsoft and basically just added strong typing to JavaScript and then cross-compiles it to JavaScript. So there are two different languages, but very similar. And ultimately, they end up in the same format so that the runtimes can deal with them. And the runtimes is another thing that people underestimate how complex that is in JavaScript. So let me delve into that a little bit. So unlike language ecosystems like Java, where there's just one Java virtual machine and that's standardized, the JavaScript ecosystem is a bit more complex in the sense that there's multiple web browsers and they all sort of behave similarly, but a bit differently. And believe me, I know about that because I've been dealing with like Internet Explorer back in the day, and it has gotten better, but it's still terrible when you look at web application development. And then those server run, so the JavaScript can run on the client, so on your browser. It can also run on the server. So there's runtimes Node.js, Dino, and Bun. It can also run on your desktop computer via sort of like a simulated runtime that's like a cut-down browser. It's called Electron. If you're using the Slack desktop application, you know what I'm talking about. This is just basically also a web application. This doesn't look like that, but it is. And the same for Visual Studio Code. So there's lots of different runtimes, and these runtimes are powered by different JavaScript engines. So the big ones are V8, SpiderMonkey, and JavaScript Core. Right? So there's quite a bit to cover in terms of complexity of testing and how this works, but with the great culture in the JavaScript ecosystem that I've also observed recently again at JSConf, they make it work, or / we make it work, and that's amazing. So when I talk about JavaScript libraries, we really talk about packages. In the JavaScript ecosystem, they're called packages, and the npm tool is what creates those packages, and used to be the only one. Now there's multiple. We'll talk about that in a sec. But the repository, or like large publicly available server that provides that, is called the npm registry, npmjs.org or /.com. Used to be its own company / business, ended up at GitHub / Microsoft, and that's where it sits at the moment. And it is very, very busy. They get a lot of traffic. They have over 2 million packages, and it's been growing exponentially for many years. And not only do they serve over 2 million packages, so there's also a constant influx of more packages, newer library versions or package versions, and more use cases. As you saw before from those different use cases and runtime platforms, it's just constantly growing. And there's more and more happening. So the traffic is pretty tremendous on the npm.js registry. And these days, the common packaging tools used in the JavaScript ecosystem are still npm, so the original. Then there's a newer version called pnpm, which is mostly compatible, but mostly also better, honestly. And that's probably the most widely used one. There's also Yarn, in 2 different flavors, one called Classic, which is kind of the older 1.x version, and the newer Yarn, often called Yarn Berry, which is like at version 4 point something now. And then there's also Bun. If you go back here, interestingly, Bun is also a runtime. So Bun is kind of like an interesting beast. It does more than just building. It also does runtime and a bunch of other things. So very interesting to see how in the JavaScript ecosystem all sorts of different things are happening, and it's very dynamic and fun to be around in. And that's also why, I guess, to some degree, it's very popular. And you can get stuff done quickly and very impressive web applications happening, and that's always fun to do, right? So if you're not in the JavaScript ecosystem, you might still hear or know about some of those names. So I thought I'll point some of those out and talk about them a little bit. So there's front-end frameworks. The popular ones are React or React.js. An older one that is called Angular came out of Google originally. I think React came out of Facebook. Both of them are big open source projects with their own community. Then there's Vue, Svelte, and Ember.js. So there's a whole bunch of those front-end frameworks, not to mention there used to be lots more. They kind of, when you're on the outside of the ecosystem, it feels like they come and go like along fashions, but actually they're quite long-lived and like very cool projects. Backend frameworks, Node, I already mentioned, or Node.js. There's also Express, Nest.js, and others. There's other frameworks that do more things like Next.js or Nuxt. Gatsby is also interesting if you are into static website generated. Gatsby is kind of like, you can think of it as a React version of a static site generator, similar to like the good old Jekyll or Sphinx or Hugo, if you know from other ecosystems. And then there's lots and lots of mixed libraries, Lodash or D3.js, for example, for visualizations, very powerful, or jQuery is like a core library for DOM manipulation in a web browser. Very old, but still around and kicking to some degree. So lots and lots of those libraries and packages are out there. So these are all things that we serve in the npm or /Chainguard libraries for JavaScript. Now, why is that important? Well, here's a good example. In the recent attacks that happened, also known as the Shai-Hulud attacks, or around a number of packages, there was basically an attack on the maintainers of some of those packages, and those maintainers just got cheated into giving up their credentials, and unfortunately that was successful for some of them, and then these packages, these security kind of attackers created packages that look for crypto tokens and identifiers and stuff like that, and they published binary versions of those into the npm registry. And as you saw before in the supply chain, if you go back here, right? So this supply chain, the maintainer was compromised, and the attackers put binaries right into the distribution right here. And what then happened is that all the developers, as usual in the JavaScript ecosystem, you just like update very often. They just update to the latest version. With that latest version, they got the malware, and then all sorts of fun happened, aka not so good. But the maintainers were kind of uninvolved, and the source code, and that's the important part, the source code was not compromised, because the source code authentication on GitHub is typically two-factor authentication, much tighter control. And there was not so much phishing attacks going on. I fully expect that to also happen more in the future, but there's a lot more controls in place. However, in the distribution channel, in the npm registry, that was still not as mature, so malware snuck in there. And that had some tremendous damage, but it didn't affect Chainguard Libraries for JavaScript at all. And why is that? Well, because Chainguard Libraries for JavaScript only builds packages from source. So if there's no source, which as a malware author, you probably don't want to put your malware source code in the GitHub repository. And also specifically, you couldn't, because you would have to steal the GitHub credentials for that project's repository as well, which is a whole other level of complexity. So Chainguard Libraries for JavaScript was not affected by any of those. And in fact, Charlie and Derek, you can see in this blog post on here if you want to learn more details. We did an analysis of a couple of thousand of these malware attacks that happened in the JavaScript ecosystem over the last couple of years. Chainguard Libraries for JavaScript prevented 95% of those because they had no source. And then it also presented more, like about 5% more, which is kind of like basically well over 99%, because there was no matching source, right? Like if the malware is one source code, but the actual source code of the package is another source code, then even if they ship the source code, we don't use the source code that is a binary that's like shipped to the npm registry as a bundle. We actually look at the GitHub repository, or like the source code repository. It can also be in whatever else. It just happens to be that nearly all libraries in the JavaScript ecosystem are on GitHub. But we also could go to any other GitLab or whatever. So overall, you can see that Chainguard Libraries for JavaScript prevents 99% of all the malware attacks on the npm registry. And that is by far it's also well over 99% of all the attacks on the JavaScript ecosystem. So it basically prevents all these attacks, and like from the start, you don't have to worry about it. So what is it? How do we do this? Well, Chainguard Libraries for JavaScript, we basically take all the packages from the npm registry and we rebuild them from source in the Chainguard factory. So Chainguard factory is our whole build infrastructure that we have, from building the Chainguard OS, Linux kernel for Chainguard VMs, all the packages, OpenSSL and all that stuff, all from source in a SLSA 2 certified, very secure environment with monitored during the build, locked away from the internet and so on. We built them from source. And then we provide a new registry as a replacement. This libraries.cgr.dev/JavaScript, right? Like /Java is where the Java one is, /Python is where the Python one is, /JavaScript is where the JavaScript one is. And those libraries are only available with authentication. So you have to have a pull token, what's called a pull token, to access it. And it has no malware in it. We also don't ship any packages that have pre and post install scripts. So all of those security issues from these JavaScript libraries basically fall away. And it's actually super easy to use. In all these packaging tools in the JavaScript ecosystem here, examples for pnpm, npm, and yarn, you have a concept of setting a registry, so the source of those packages. And you can see here in pnpm, you just go config set registry, and that creates a .npmrc file where that entry is added. Similar, for example, here, this is for an example for direct access. So where you would directly go to our registry. Ideally, you actually want to go via what's called a repository manager. So a repository manager is like a separate application that acts as your own private registry in your company. And then you could do, like, if your company is called example.com, you can, and it's deployed at 8.4.4.3 for HTTPS traffic. And this is, for example, a URL that you could end up using if that would be running on that URL, something like Sonatype Nexus or JFrog Artifactory or Cloudsmith. And then a similar example for Yarn. Yarn just has a npm registry server name here, a little bit different, but ultimately very much closely. And then all you would have to do is clean the cache, look at your log files, and rebuild. And you'd be back in business with a replacement. I'll show you that in detail in the demo. As I mentioned, the repository managers, you can use direct access, but in an organization, that would mean that all the developers would download all those packages all the time, and also don't necessarily easily have access to private packages within your organization. So you want to probably use something like Sonatype Nexus or Artifactory or Cloudsmith in your organization anyway. And Chainguard Libraries cleanly supports that, and you can easily use that. So there's also other ones like Verdatio or Google Artifact Registry, Cloudsmith. Verdatio is one that only works for the JavaScript ecosystem. So depending on your use in your organization, you might need something else because it might need to support multiple repository formats, also Python or whatever. And both Nexus, Artifactory, and also Cloudsmith do support all that. And our documentation includes that. I'll show the resources on that a little bit later. So what other benefits do you get out of Chainguard libraries? Well, all the packages, when we build them, we sign them. And that's sometimes important if you need to prove where those packages come from. We also add full SALSA level 2 attestation, which means there's information included like it was built from that specific Git commit on that specific Kubernetes cluster and worker node in our Chainguard factory. So like the reference to Chainguard is also in that information. And then lots of details like the timestamps and like there's a lot. There's a whole JSON file that you can look at and potentially download and keep for your reference and your records, depending on what you need to prove on your compliance and so on. This provides all the details. We also include SBOM files. So SBOM stands for Software Bill of Materials, which basically says, this is all the stuff we're shipping you, right? Like all the things that are included in this are detailed. Also often includes links to like the dependencies. So when you build an application that has multiple dependencies in it, which is nearly often or nearly all the time the case, then having that information also all consumable and point us to what these additional components are and what they come from, maybe even the license information, all that's also very important. As I mentioned already, we prevent pre and post install script attacks by monitoring when we build the application or a package. Sorry, the package, not an application. We only build the packages. When we build the package, we then also do a test install of the package. And then in that environment, we look what it's doing. And monitor its network traffic and that kind of stuff. So if it does anything bad, then we prevent that as well. So we will take those scripts out. And then the next benefit is you can also verify all that. There's a tool called Chainguard that we provide, just a command line tool that allows you to verify all that information as well. So you can basically point it at a Docker container or so and see, hey, are these components in there from Chainguard? Which ones are not? And then that at a minimum allows you to tell, well, there's these proprietary ones, like the ones that we wrote, like that you wrote yourself in your organization, or other ones that, you know, they're proprietary drivers for your enterprise database or your AI tooling or whatever, where there's no open source tools available. You can also then adjust the risk of those components separately. So it allows you to better understand how secure your posture on your overall application is. So this is all benefits you get from all the Chainguard libraries, and obviously also from the JavaScript ones. So that's a first round of where we want to go. Let's have a look at our demo, or at a demo for Chainguard libraries for JavaScript. So I'm going to jump over here, put this away for a second, and go over here. So I have a little script. Let me make this bigger. I have a bunch of example scripts here. So if you look at this, make me make this big. Oops. Hopefully that's not too big. Oops. So this example script here, I have Nexus running in the background as well as a repository manager locally. But I have this npm test script. So let's look at what this does. So it basically initializes a new npm project. It then configures direct access. So what this does is it takes the Chainguard JavaScript identity. So this is a access token username, so to speak, and then the Chainguard JavaScript token, that's like the password, creates a token that it then SHA-base64 encodes, and it uses that token as authentication token to the Chainguard libraries in the npm configuration here, right? So it basically assembles, sets the registry. So that's going to create a .npm rc file in the local directory, which I'm creating that as a new directory called test npm. So I can repeatedly run this demo, and you could too. And then I just add a few components. You command pico colors, so it doesn't take so long. I edit only a few, and I run an npm install. The project itself doesn't do anything. It's not an actual application, but I don't want to teach you how to write an application. So there's probably better people to do that. And we just want to talk about the dependencies here. So let's run this. Boy, what is happening? Well, that is not what I had in my demo happening before. All right, that's weird. All right, I don't know what is going on here. I literally tested this earlier today. All right, well, let's just switch over. I don't know. I don't want to waste your time debugging this. So what we're going to do instead is I'm just going to switch over to my Nexus that I have running locally. I'll show you that as well. And maybe we have better luck next time with the, actually, let me check this, JavaScript. Yeah, okay. Let's go this. So if I run the script again now, you see it adds the packages one after the other. The difference that I did is I didn't access the registry directly. I accessed this repository, which is a mirror in my local Nexus instance. So if I run this here, let me just fire up local Nexus here. So you can see localhost 8081 is where my Nexus lives. And if I go browse here, I have all these repositories, and there's the JavaScript npm repository, and there's a bunch of stuff in there already. So this created the repository. Now, if I go into this project and you see this, the test project it created, you see the node modules here. These all came downloaded from our Nexus instance, which downloaded it from Chainguard Libraries for JavaScript. Now let's see if pnpm is my better friend today. Okay, something with the registry is not happy today. I literally want the the ecosystem team that they shouldn't make a mess of the server today. But at this stage, who knows what's happening? It might also be my fault. It's trying to download this. The pnpm script is doing the same thing here. Again, it sets the token up and then downloads the packages. The difference is that pnpm, you wouldn't see the pnpm test project. It is here. You can see the project got created, but there's no folder because pnpm works differently. But you can also see the npm-rc script here has the auth token and the libraries access in here. So that's how it works with pnpm. So this is not happening either. We can point that over to change it over to point at the local Nexus instance as well. Then we'll at least get a successful run happening. So I'll just change this over again to the Chainguard. Oops. Comment the configuration for the direct access out and run this pnpm test script, and then it works fine. So there must be something on with my internet connection or with the traffic to the registry server at the moment. Who knows? Anyway, hopefully this is all interesting here. And you see in both cases, the npm-rc file got created. This here just points straight at my localhost Nexus instance, which I have set up to not use any authentication. In an enterprise environment, you would obviously set it up with authentication either via a token or a username, but that doesn't matter here for my local deployment. It makes it easier. But in Nexus itself, the configuration, if you sign in here, the configuration for this repository, if you look at the JavaScript Chainguard repository, it points at the JavaScript repository, and it then has the authentication here with this pull token, which how to create that is documented, and I'll show you the link to that later on. So that's Chainguard Libraries for JavaScript in a nutshell. At the moment, we're building up to build more and more of those components. We're already building a whole lot of packages, like literally many thousands. But it's going to go into, well, it's probably more in the 10,000s, and we're going to go through the hundreds of thousands. We are building it up. It's in a closed beta, so if you're interested to try it out in your organization, please do reach out. We're building it up so that we get full coverage for all of our customers one at a time, sort of like scaling it up. But it's already very usable, as you can see. Like, we are dogfooding it for our own website, the documentation website, and it's working fine for that. So should also work very fine for our closed beta customers, and then soon for all of you. All right, as promised, here's a follow-up. After a whole bunch of debugging, thanks to my complex setup locally with repository managers in the cloud and locally, and all the different JavaScript build tools and all the different caches installed, there was some mess up that just like did not let that demo work. But we got it all cleaned up, and I learned a whole bunch of things about yarn, berry, pnpm and npm and URLs, and even worked with Charlie to dig into the code. So it's been interesting, and I'm going to share now what I got going and show you all the demos working and some of the lessons learned. All right, let's get right into it. You have my example scripts directory here, and there's the 4 scripts: npm test, pnpm test, yarn berry test, and yarn classic test. They're up on the screen here as well. There's no temporary directories. All of these scripts basically create their own folder for the project, initiate a folder, and then configure the registry access, and then get some packages. So let's run those. Here we are in the same directory, /npm test. Configures, adds a package, downloads it nicely. So number one, next one, more modern, pnpm test. Faster, but also gets them fine. Next one is Yarn Classic, the old Yarn version, 1 point something. Also works okay. Has different output as well, of course, as you can expect, but does the same job. And then Yarnberry also, and it even has a bit of a authentication because it does a Git repository. So I'm 6-door configured, and it does a bit of Halloween as well. You see, it's the 31st today, so you got some pumpkins to see, so it's all good. All of those are working. So number one, we're happy about that. Now, what actually happened? Let's have a look. We have the 4 example projects here, and each one of them has a npm-rc file configured. You see here registry JavaScript, and then it has, this is the npm one, the node modules here downloaded correctly from our registry, and you see here it created the dependencies entries here for the project. Same idea on the npm side. Same thing. In the npm side, I added a pnpm side. I, in this case, configured the username and password authentication. A bit different, and I'll dive into those details in a second. Yarnberry, oh sorry, let's go Yarn Classic first because it's the older one. Yarn Classic here, package JSON, and then the configuration is in the yarn log file. You see here, it logged them all, got the packages from there, Yarn itself, but then the node modules came from our file, and then Yarnberry, the Yarn.rc file here has the authentication for the registry here in its separate YAML file format, and the package dependencies within the package JSON file. So all those 4 projects now worked. So we are happy about that. Now the interesting bit is, why did they work and what did we change? So the npm test one, after clearing out all the caches and removing all the headaches that we had, we found that npm really likes to have a trailing slash, and npm also prefers to use this configuration of the token for authentication, and you have to base 64 encode it. Be careful also if you're on Linux or Mac, base 64 encoding might be giving you headaches depending on what base 64 version you're using. Unfortunately, there is differences between the operating systems, but this is the best way to work on any npm side in our experience. The username and password authentication is supposed to work in npm. Not so much for me anyway. So stick with this one if you need to. npm use, same idea. Make sure you have that URL with the trailing slash. Also, again, as just like in pnpm and all those configurations, you need to make sure that the trailing slash is there also when you configure the authentication. In terms of pnpm, the authentication, both works. The one where you use the token, that's base 64 encoded here as well, that works. It also works if you use that username and password. And also note that it's underscore password, but username has no underscore. And you just use the environment variables. The advantage of that approach is that the base 64 kind of like irregularities between operating systems and versions disappear and you're clean there. Also, when you configure this with location project, so that there's a local configuration, so npm-rc file created, as you can see here, right? Like the npm-rc file is in the directory of the project. Make sure that you have that same location pointer in all the different invocations and don't mess that up. Or also, if you like do it globally, then do the global one. So those are npm and pnpm. Note that it prefers to have the trailing slash, both of them. Now Yarn Classic prefers to not have the slash. So when you configure the, in fact, it makes weird error warnings or fails completely depending on version. So do not have the slash here, do not have the slash here. Same idea, use the token with the base64 encoding on the Yarn Classic version. On the Yarn Berry version, on the other hand, again, don't use the trailing slash, but you can avoid the base64 encoding because Yarn Berry has an npm auth indent identity parameter that allows you just to use the colon separated username and password from our pool token right here. And then also you might want to set this npm always auth. In this case for Yarn, for npm and pnpm, those parameters are actually deprecated because they weren't actually working. So it authenticates all the time anyway. So this is the only one where you might want to do that. And that's what it takes. So pay attention to slashes and not slashes and the different parameters, and also be very wary of your local caches going on, because each one of those on different operating system has different caches for registry information and all that kind of stuff. But you can see it was all working just fine on the server, and it was entirely my fault for over-engineering and over-complicating it all locally here. So sorry, I did test it before, but you know, the demo gets one out with me this time. But now let's move on to the CVE remediation on Python, where the demos did work, and that's awesome. But let's talk about Python and CVE remediations next, because that's also super exciting and interesting. So again, similar to JavaScript, the Python ecosystem is also quite big and has lots of components. Some of the names you might have heard of here, I put some representative logos in. It's like Django here, for example, PyTorch, Everstorm, or this Flask. Lots of those little components are available in the Python ecosystem as well. And Patrick already did a learning lab about this a while ago, so I'm not going to delve into the details there. It's pretty much the same as what we talked about in JavaScript today. You have a different URL and the component tools are different, but otherwise it's similar. The great news about Chainguard libraries for Python is that it's generally available now. So it's at a level where we are very happy for our customers to get on board, use it in their production and scale it up. It's running, humming along. And it includes, and that's what I want to talk about today, CVE remediation for popular packages. It supports the typical build and packaging tools in the Python ecosystem these days. The old pip is probably getting less popular. The new kid on the block, or well, not so new anymore, but UV is probably the majority these days. It's very fast and very nice to use. And then there's also Poetry, which still is out there as well and being used quite successfully. We also, and this is important for the CVE remediation to show, and I'll demo this later on, we also have a growing support for various security scanners, like examples that we already have working out, Grype and Trivy, and there's a whole bunch of news on more coming. So stay tuned if you are a Chainguard Libraries for Python user. But let's talk about CVE remediation. What is that even? So we essentially use fixes from the upstream project. So imagine there is a CVE vulnerability detected. The open source project will be notified or will find out about it, and then someone hopefully will create a fix. However, that fix will be released and built and developed for the latest and greatest and newest version, and that's where that fix is available. What we now do is we backport those fixes to older releases, and that enables you to use a version that has that CVE fix without having to update to the latest and greatest version. And that's often very important, because going to the latest and greatest version might mean that you have to refactor and change and like there might be breaking changes from version to another. Yes, you get the new features of that new library, but you also get to take care of all the changes. And just to get rid of a CVE is not necessarily worth the effort, specifically on applications where you're just maintaining the application pretty much. You're not actively developing, and you just don't have enough time to take care of all the updates and always run on the latest and greatest version. In an ideal world, that would be the case, but unfortunately, that's just not the reality. And if you are in that ideal world, you can still do that. And you would still benefit from our libraries in general anyway, because all the malware and all supply chain issues are also removed. And we might also even look at CVE ports where they get backported to create non-released version, right? Like say, for example, a project merges a fix for a CVE, but they're not going to cut a release for another 2 months. Then we could also create a CVE remediation for that. Not that common to happen, but it's also something that our tooling would support. So what then happens is we create basically a new patch release with that fix in it. So with each fix. So if there are multiple fixes, then it would be another fix. So here, this is the example version 1.2.3, and we add this what's called a local version in the Python ecosystem, CGR.1. So if there's another CVE being fixed, then we add CGR2, CGR3, and so on. And all of those fixes are available in a separate repository. You see here, library CGR dev python-remediated. The reason we do that is so it's easier to find them all, and it's also easier to vote in, opt in and out, right? Like if you don't want to have any of those remediated libraries in your list of available things to work with, then you just don't proxy that repository. That's it. So it's pretty easy in both cases. And then we do also make a VEX feed available for the scanners to understand what the fixes are that we provide. VEX is kind of like a standard format, and this is publicly available for everyone to consume. And it does work for tools like Trivi or Grype and a whole bunch of others that can understand these VEX feeds to then basically out of that information figure out that a binary from Chainguard has a specific CVE already fixed. And I'll show you that in a second. Before we go do that though, let's talk about a little example. So the VEX feed for Flask is this URL. And now I'm not authenticated. And it should, oh no, sorry. Sorry, I have to go like this. Whoops. I am authenticated and it shouldn't. So see, this is what the VEX feed looks like. So it's like some sort of identifier, and it says here the Chainguard team supplies this information. And for example, for this release, like this vulnerability, specifically this CVE and this GitHub security advisory is fixed by, or like a fix is contained in the release of this Flask 1.1.2, CGR1, and then Flask 2.0, 2.1, 2.2, and so on. And that this information just keeps getting more and more and more, right? So there's more and more in that information. Now going back to this slide deck, if I can find it. Here. So this is the fix, the VEX feed. And then this is the two CVEs. So if you look at that CVE, specifically the interesting one is the GitHub Security Advisor. The CVE is mostly useless, or like a lot of the times, let's not call it useless. Let's call it has less details. The security advisory on GitHub seems to be where lots more is happening. You see here, there is a very useful link to the merges of the PRs that fix that, the link to the URL of the tag that released that fixed it, and you see here this was fixed in 2.3.2. So this security advisory contains that information, and then we take those two commits or changes, in this case commits, and put them back into older versions. And if you look at that, oh no, sorry, in new tab. Oh, I thought I logged in before. I guess not. Okay, I have to log in, which means I have to use my pull token, which is just very long. This is not an issue because my pull, like that, I'm demoing this to you because A, the pull token is ridiculously long, and B, it expires all the time. So I can show you this just fine. And you see here, these are the versions available. So this is our Python remediated, as you see, simple Flask, and there's the different wheels with the fixes in it. And then let's make this again bigger. So this is the wheel. Oops. So this has those files, and you saw the table. So here there's the 2.0.2 plus CGR1 is, for example, a one that has the fix in it. And then, so users that were using 2.0.2 of Flask can upgrade to that version without having to deal with all the changes that happened since 2.0.2 to the one that has the original fix in it, right? Remember here the release fix was 2.3.2. And as you can see, this is a minor version. So from 2.0.2 to 2.3.2, there's probably a whole bunch of changes in there that might or might not break your application. So if all you want to do is fix that CVE, then this is the sort of like much easier, simpler approach to take care of. So I'm going to show you this in another demo now. And hopefully the demo codes are more with me now than they were before. But that's okay. So we'll go, I have this demo prepared here in example projects. And there is a UV example. And I'll show you what this UV example does as well. So let's make this smaller, UV example. So this UV example here has a test script, and all it does is it creates a new Python environment to basically create everything from scratch. So like clean everything up, and then it does a UV build. And the interesting part is the PyProject configuration toml file. It for now points at my local nexus, the Python all context, which does not contain remediations. So let's run this. Oh yeah, and then the interesting part is of that is that at the end, like it basically downloads the dependencies, does a UV log, and then it runs grype to show you and analyze this virtual environment and analyze what is available in terms of like what not available, what is affecting us in terms of security issues. So if I go .run test, it's just going to run through a whole bunch of things. Yay, demo codes, thank you. It's downloading this, fine. So we'll have to go back to the JavaScript one later, and I don't know. Hopefully we'll get some better. You see this is grype running now, so the build already passed. You see here it downloaded the various sources, ran the build. It's now just getting the vulnerability database and does the scan. And you see here there's a whole bunch of different GitHub security advisories that are affecting my project because I built from Chainguard Libraries without the CV remediation, right? So the code of those packages is essentially the same as upstream. So it has the same security issues, but it is like doesn't have the malware and supply chain attack issues. So it's better than what's upstream, but it still has these issues. So what are we going to do? Well, I can show you in my demo. We'll switch over to use the Python index in my Nexus repository, I mentioned it does contain the security fixes. I'll save this and run the build again. Remember, it wipes everything, does everything from scratch. And interestingly enough, you see the installed version changed. So all these versions of these libraries changed. So there's now Werkzeug 302 CGR1. So it does contain the fix. It still has issues, but they're only medium severity issues, right? Because in Chainguard libraries, in the CV remediation, we only take care of the high ones. But you see all these high ones that were here for Werkzeug, Flask, and Setup tools, they're all gone. And that was like a one-liner, a one-liner change on your end, right? Like all we needed to do is basically activate the remediated libraries to come in, and then we're already in business. So very nice setup. So that's what CV remediation does, and I think that's pretty amazing. Props to Wesley and the team working on all of this. There's a lot going on, and it's pretty cool to see the aspects, like the output of that so easily. Now I go back to, no, not this. Go back to the right one, this one. Yeah, this goes away. Go back to my slides, hopefully. So that's CV remediation for libraries for Python. Super cool. In terms of resources, if you want to learn more, we have the website, we have the education documentation as well. There's all the details there for configuring the repo manager and stuff like that. I will show you a little bit about this. So here we have Chainguard Libraries, right? Documentation. If you go scroll, make this a bit over here. Scroll down here, there's a separate section for JavaScript, which contains an overview, the global configuration for Cloudsmith, JFrog Artifactory, and Sonotype Nexus, how you configure that in your repository manager. And then also lots of details on how to configure the different tools, right? Like this example that I showed you with pnpm is pretty much that, so you can do the same thing yourself. And then also with this, how to encode the token and that kind of details. And then on the Python side, same thing. We also have the details on the CV remediation and the vulnerability scanners here in the vulnerability scanners documentation here, grype and Trivi. So you can replicate all those setups and play around with them as you like. Now, next up is we will have more cool webinars and learning labs. As Lisa already mentioned earlier on the 20th, we have Chainguard OS on Raspberry Pi, you know, those little computers that you can plop wherever. Chainguard OS, so the virtual machine full stack runs on Raspberry. Quite amazing, and Eric is going to show you that. We also on the 13th of November have a Chainguard product announcements and feature releases kind of panel with our product managers, and then another panel with our Chainguard founders on the 10th of December. So all of those events are good.
Manfred, we do have a hand raised. Yannis,
Yeah.
you want to join the call, or?
I don't know how to, can we let him on?
I think I tried to do that, but I don't see Yannis.
Okay, what do you recommend for packets that don't point to well, let's look at some of the questions anyway. So Toby is asking, what do you recommend for packages that don't point to source code? Well, those packages are not trustworthy. So there's kind of two aspects to that. If like all the packages that go and get deployed to PyPy, Maven Central, and then the npm registry have to point to some source code. And we use that to build the package because that's the authentic source from the maintainers. If a project doesn't point to source code, for our all intents and purposes, we consider it untrustworthy. So we don't publish the package. And if it points to elsewhere, like, you know, like you publish one binary, but you point to some other source code, then that's also not trustworthy. And we don't consider that as well.
Yeah, so
Now,
I think I answered most of the questions. Let me see if there's any that were like particularly juicy here. Yeah, so I don't know if you want to speak a little bit more about attacks on the source code repository came up a few times. Interest in malware.
okay, well, let's talk about the source code repository. I don't know if there's any known attack that was actually affecting the source code repository. Theoretically, it's possible. Practically, it's pretty hard these days. Best practice on pretty much all open source projects that I'm involved in it that I know of are at least two-factor authentication, often also signed commits with like Sigstore or other things like that. Like that's what we do at Chainguard, for example. So for someone to compromise your GitHub account, they would have to basically completely steal your identity, like including your two-factor phone authentication device or your security YubiKey on your laptop and all that kind of stuff. So that gets pretty involved. I think there's probably easier ways to hack things then.
We have a question in the chat about a risk from a rogue developer.
Okay, so yeah, that's an interesting one. What's a rogue developer, right? Like pretty much all code review, like all pull requests on like active open source projects are maintained by multiple people, right? So that then means that these multiple people know each other and review each other PRs. Like I'm involved on a Trino open source project, for example, and I can't merge a PR that I create without someone else approving it. Like even though I'm a maintainer and I have the power sort of to like the authority to do some of this work, I can't merge someone else, like my own PRs without any approval from another maintainer. And then if you're not a maintainer, you have even less rights. There is one project where this happened in the past where a maintainer came in and worked many years on a component as a full-on maintainer and then turned. And this was or seemed to have been a planned attack, but even then it was like detected a few days later. And so that's very unlikely, and that's a lot of work to do that, so not that common. I also suspect this is going to get even harder because more and more people are aware of those kind of risks.
There's a new question from Toby. Is there a chance of getting a package that is ahead of the published version if you're building main and the latest published version is a bit older, for example?
Like who is building from main? Like we? Okay, I know what you're asking. Yeah. So Chainguard does not build from a main. Chainguard builds from the release tags that are the tags or branches or whatever, like whatever is used for a specific release of a specific artifact. We don't build the latest and greatest main because that's depending on the open source project, that the culture there is like different. Some have main always stable and theoretically always useful, but a lot of them also like, oh, let's throw this in, test a little bit, and we'll get it ready for the next release, which is another 2 weeks or so. So main can be pretty good, but can also be not that good. So that requires a lot of knowledge of the individual project. We do that on a lot of stuff on the like Linux and like lower level packages for Chainguard OS, but on the libraries, we don't do that. At least not yet. Maybe we will in the future, but that's a long term in the future potential. Any other questions you found, Lisa?
Yeah, there's with active measures by GitHub on eliminating long-lived tokens and the soft push towards trusted publishing, how do you see it? Do you think the frequency of malicious packages will cool down significantly with the planned GitHub measures? Yeah, these, I don't know, these are very late breaking. Like I think just today or yesterday, there was some new news about GitHub.
Yeah, the trusted publishing and all that kind of stuff is a good thing. Hopefully some of these attacks will get less. At the same time, with all the AI tooling and stuff, finding exploits, making sort of finding issues and making exploits, and also creating applications that have all sorts of security issues is becoming easier and easier. So I think it's kind of like an arms race, and we just try to stay on top of it and do even better than what's available from the public registry and all that tooling, right? Ultimately, we'll see, right? I strongly believe there's massive value in using this, because it just makes it so much easier to not worry, even if it covers only 90% of the libraries that you're consuming and using, because the rest of them are CUDA libraries from NVIDIA or whatever commercial database drivers. It's worth just not having to worry about 90%. So that's where we're at. Any other questions we want to talk about?
Yeah, I answered them all. I think a few people are asking about lunch, and for those of you who attended live, there's an email that's being sent out tomorrow from the team. And I just want to thank everybody again for joining, and have a happy Halloween.
Yeah, thank you so much for joining us, and we will be back with another Learning Labs. Erica is going to be the next one. Make sure you